might find it helpful in doing your homework assignment. Toward the end of our discussion tonight, I'm going to do some problems similar to what you need to do on 1 and 2 of your first project problems that's due Thursday. Okay, so you might have already done it, because I know some of you already found it on Blackboard days ago and so forth. In the directions on your assignment, I put forth that you could solve an equation, or you could use the table on your calculator and narrow down, and that's fine. Either way is fine. But if you were going to solve an equation, the type of equation you are given is an exponential equation, and so I'm just kind of reminding you about the connection between exponential functions and log functions and how to solve equations that involve them. Okay, so if I were trying to solve this equation for x, I'm trying to get x by itself, and so I'm trying to undo all of the order of operations that have been done to it, okay? When you're solving an equation, you do the order of operations in reverse from what you do arithmetic. So if you're kind of following your PEMDAS, we're going to change the E to F for function, okay? Because in pre-algebra, your only function is exponents, but by the time you get here, we have all kinds of other functions, okay? So parentheses, function, multiply, divide, add, subtract. Okay, that's the order that you're supposed to do arithmetic. When you're solving an equation, you go through those orders backwards. So if I had any adding and subtracting in my equation, I would cancel that first. I don't. The ones I put on the board, I don't have any adding or subtracting. So then I want to undo any multiplying or dividing. So I'm multiplying by 60, so I want to divide by 60. Alright, so I've canceled the multiplying that I had. Now I'm to the main function. So I want to cancel the main function. Well, the main function is an exponential function with base e. Its inverse is natural log. So I'm going to take the natural log of both sides, because when I take the natural log of both sides, plugging e into its inverse function cancels. I'm sorry, I'm going to need that space. I should space these up there. Okay, so taking this function and plugging it into its inverse cancels the idea of the exponential function, and you're left with what was plugged into the exponential function. What I did right here in terms of concept is no different than if I squared a square root. All of this is just notation to mean something, okay? This notation means the inverse of this notation, and vice versa. Okay, so any function plugged into its inverse, what happens is you're left with what was plugged into the original. That's what you're left with. So then, to finally get x all by itself, I need to divide by the 0.5. Notice that this is sort of what was in the parentheses. So notice the very last thing I'm dealing with is what was in the parentheses. And from there you can clean it up. Ln of 20 over 6 can be reduced to ln of 10 over 3, and you know, I'll just leave it like that for now. Below it, I had basically the same equation, but instead of a base e, I had base 2. Okay, so process starts off the same. You undo any outside adding and subtracting. And then I want to cancel the exponential function, but it's base 2 instead of base e, so I'm going to use log base 2. And that leaves me with, so plugging this into log base 2 does the job of giving me what was in the base 2 function, and then I divide by the 0.5, and I'm left with my x. Now, if you wanted a decimal approximation of this one, okay, I mean that one you can just type it like it looks on your calculator. If you wanted a decimal approximation of this one, your calculator doesn't have an automatic base 2 button for log, and so you use a change of base formula, and any base can be rewritten as another base by following what I just did. I wanted to change from base 2 to base e, and so you take the base you're changing to, okay, I'm changing to base e, natural log of this number divided by natural log of that number. Okay, so it's natural log, if you're changing natural log, it's natural log of the input gets divided by natural log of the old base. And if you type that in your calculator now, you'll get a decimal approximation. Otherwise, this is an exact answer. Okay, there's nothing wrong with that answer. It is an exact answer, but if you were trying to get a decimal, you would need to use that stuff on your calculator. Okay, and then the inverse, if I had basically the same equation, but I started with logs instead of with exponential, again, all equations start off the same. You work from the outside in, you undo any adding and subtracting, then you undo any multiplying and dividing, then you undo the function. And so because I have natural log as my main function, to cancel that, I need to use its inverse, and its inverse is e. So technically, I'm going to plug this in as the exponent on e, and all that is notation that means, hey, those two things cancel each other, and from there I can clean it up, but that would be your final step. And then this one, I would divide by the 60. And then to cancel log base 2, I'm going to raise both sides to, the 10/3 is what you get if you reduce the 200 over 60. So to cancel log base 2, I use exponential base 2. And again, all of this is just notation that means these two things cancel each other. And so I get 2 to the 10/3 equals 0.5x, and then your last little step is divide by 0.5. Alright, so I just kind of wanted to jog people's memory about that topic. Okay, because again, the first two problems, or at least the first one, I can't remember. I know the first one's an exponential function. And what you're asked to do, you could do it by solving an equation, or you could just use the table on your calculator and keep keep adjusting the inputs on the table to narrow down to what you're being asked. But if you wanted to solve the equation, I was